Elixir Zone. I've been off for a little while because I've been preparing some really long presentations. I'm not going to do those today. Today I'm going to start finally getting into actual Elixir instead of all the Erlang and other stuff we've been doing. Elixir Zone will finally include a little bit of Elixir content starting today. We have 3 episodes lined up, all Elixir. I'll be doing it with LiveBooks. I think you're going to like it. They're fun to play around with. I'll show you all that. Just a few brief words first. I wanted to say that part of the reason I've been unable to record anything recently, I've been waiting for about 2 weeks to record this. My laptop refused to, the webcam stopped working basically. And I couldn't figure out why, and I finally figured it out last night. My version of Mac OS was too out of date, and somehow that broke something. Kind of plays into what Joe Armstrong said in one of his talks about everyone's computer state being different from everyone else's, because I tried solutions, just as he said, that did not work for me, that had worked for other people. Finally, I found somebody who had said that they had to update their OS to get it to work, and that's what worked for me. But it took a week and a half of research to get it working. Computers are hard. I'm still working on the Elixir Fundamentals episode 4, which is going to be distributed intelligence, but that's going to be a while till I record that. Also been working, it's been spiraling out of control, the number 2 episode on tech management crisis. A lot of great material for that, so still letting that gel. I'm going to jump into today's first actual Elixir Zone, but before I do, let me give you a roadmap for the first 3 shows that I'm going to show. Today we're going to cover LiveBook, which I will discuss and show you at length. We'll cover functions of various kinds, like anonymous functions, multi-clause functions, etc. Modules, structs, maps, guard clauses, multi-clause functions, I think I said that, aliases, stuff like that. So sort of fundamental core features of Elixir that you probably can't get by without. And we'll skip some of the more esoteric stuff. We'll get into, in episode 2, we'll start actually building out a real module that you might use. We'll develop it over a series of refactorings and extensions. We'll introduce type specs. We'll introduce ExUnit for testing, for example-based testing. We use stream data and types, type check, to do some property-based testing. That'll be episode 2, which I hope to record hopefully tomorrow night. And episode 3, which I've also prepared, and maybe later this week I will record. We're going to look at Vega Lite, which is something I had fun playing with a week and a half ago. It allows you to do lots of graphing of data inside of Elixir and your LiveBooks. So that'll be the 3rd episode. For now, let's start jumping into this. So this is the livebook.dev page, and the Elixir team has come up with yet another home run here. Back in the day, I used something called Jupyter Notebooks, which I think originally was called IPython Notebooks. And they were pretty cool. It had some, the really cool thing about it is you could interact with the page and write code. And you had different cells and you could mark up the page with Markdown or something. And these pages were really cool. They had some limitations though. One was that pages would get stale, or blocks of code would get stale because they would run in different orders. The LiveBook people have sort of solved that problem very intelligently using Elixir. Another problem that I encountered back in the day was that the code that you put into this wasn't easy to get out of this, into the Jupyter Notebooks. The Elixir team with LiveBook has done a brilliant job of that. You can export your code as scripts, but you don't even have to do that. You can, every LiveBook, I'll show you right now. Every LiveBook, you display it in a graphical window, which I will show you in a minute. We'll interact with it. But under the covers, what's going on is just this basically Markdown. And this is the actual text file holding all the stuff that we're about to cover in this episode. We'll go through all this. Right before this talk, I actually just added this section in, and I pushed this just half an hour ago, 20 minutes ago. I pushed this to GitHub in the repo. I have just to remind everyone, there's a Elixir zone repository in GitHub where all this code lives. So the Erlang Fundamentals, the 3 courses I've presented, or the classes I've presented so far are there, the code for that. And the code for today's talk and the next 2 talks is here. So this file, which is what I was just showing you, is the content that I will talk us through today. And I may reverse the order of these, but basically the Vega Lite material is here, and the MyVal, sort of the module that we'll build out in 7 progressive steps, is right here. So you can follow along at home, or you can even get ahead because I haven't recorded those episodes yet. But it's all here, so in the Elixir Zone GitHub repo. But yeah, the key thing is that all of this is just stored here. There's you stick all your Elixir code inside this little the backticks with Elixir, and it just displays and is runnable as Elixir code. But it gets saved every time you make a change in LiveBook. It updates this text file, so you don't even have to hit save. It just happens automatically if you want it to. And then if you accidentally jump out of the LiveBook into something else, the code is still there. Nothing, if it's been saved to disk, it's still on disk. So we're going to dig into this, but enough talking about what it is. Let's actually look at it. So first of all, how do we start it up? This is the LiveBook GitHub page, and you can read through all the amazing, this is the Vega Lite stuff that I mentioned we'll do the probably 3rd episode on. You can look at some of the benefits, but here's the key. So running locally. So there's different options for how you can run your own LiveBooks. You can install Elixir directly and then run it as an eScript. That is how I am doing it. I have Elixir installed through ASDF, which is a version control manager that covers various languages, including Elixir. And then once I have Elixir installed through ASDF, so I install ASDF, then I install Elixir, and then I run this command here, and it magically installs LiveBook, and then I just run LiveBook with LiveBook server, which we will do in a moment. There are other options. There's a Docker option if you like containers or Docker. You can also run it directly with Mix, and there's several other options which you can see on this page. They have a pretty cool looking website. So they have fly.io, which is where Chris McCord just went. He is there, and they have some very cool technology. There's the Docker option we just talked about, and the Elixir option, which is how I have chosen to install it and run it. We'll see you can do interactive data. You can collaborate as a team. You have multiple users interacting with the same LiveBook. One caveat there, security, not so much. I think and hope they're working on this, but basically anybody who can play around with your LiveBook can probably do destructive things to the computer that it's running on, so beware of that. But it is super cool that multiple people can interact with the same LiveBook. And you can see here, and you will see on my laptop in a few minutes, that it has pop-up definitions. It'll do autocomplete. The documentation is available to you. Also, and I've made extensive use of this preparing these episodes, because these under the covers get saved as regular text files. You can use Git and GitHub or whatever your favorite source repository might be to do diffs. When I created 7 episodes of, let's see if it's still there. Might have had it. Oop, no, lost. I think I closed it. But in my GitHub repo, I have 7 versions of MyVal, the module I built out, and I couldn't remember what I had added in each version, so I just did diffs between version 1 and version 2, and then version 2 and version 3. I was able to quickly go back and remember what I had added from step to step. So it's very cool. You can check it out, try it out. I encourage it. But let me jump into actually running this. So to run it, oh, that's not what I'm looking for. What am I looking for? I'm looking for this one. So to run it, actually I'm already running it. I want to stop so I can show you the command. So this is the command to install it as an eScript. And now we're going to run LiveBook server. And what happens when you run LiveBook server is, whoa, that looks really weird. I've not seen, oh, that's just a 6. That's fine. So it generates a random token as a security precaution. So it starts up on port 8080 by default, and there are various startup options that you could include if you had put them here on the in front of LiveBook server, and the documentation will show you what those options are. There's probably one to start it on a different port, but the default port is 8080. So I just copied that string, and now I'm going to go open up a web browser page there, and now we're into the LiveBook. So, well, technically we're not into the LiveBook. What we're into at this point is a page where the LiveBooks. So I opened this up in the directory LiveBooks, and now it put us into the LiveBooks directory. And you'll see that I have live Markdown files here, and these are not the ones that are actually saved to the code repository are here, but that's not what we're going to be looking at today. What we're going to be looking at today is this file. So I clicked on the file, now I click open. If the LiveBook were already running, it would say join session or something like that, and you can have multiple users join the same session, or you could have something like that. But since it's not running yet, I click open. So now we're in the LiveBook, and this is just based on Markdown. If you click on, well, I guess the header is a little different, but I did not want to do. I just unintentionally showed you how to move a section up or down. So I accidentally hit that button. I didn't want to do that. So these are all clickable. I've just gone to these things. So let's go to this one. This is a talk that Jose gave about some of the changes. I encourage you to watch that. They keep evolving LiveBook. It keeps getting better and better. It's amazing. Kino, I won't spoil the fun, but watch the talk and learn about Kino. In a future episode, we'll go into some of that ourselves, but Kino looks really cool as well. Mermaid.js is something that I will show you in a moment. I have some examples in here, but the Mermaid can do all kinds of things, and you can do all of this now within a LiveBook because they've made it possible to do it. And so if you want to use this for code documentation or any kind of documentation, all this stuff is available to you now. As I said, I install Elixir through ASDF. That allows you to have multiple versions and run different versions with different repos or whatever you want to do. I'm not going to go into the details here, but it's there if you're curious. So a LiveBook is a Markdown. It's just Markdown under the covers, so you can create all these things. If you want to know how I did any of these, you can just click on this edit button, and that gives you the basically raw text that gets converted into Markdown. So for example, code blocks, that's a code block there. Another code block. Bullet lists. Oh, that's it. Sorry, where's the bullet lists? This is a bullet list. I only have one item. That's why it doesn't feel like much of a list. There's different ways to create links. The simplest way is just this. If you want the text to be equivalent to the link, here the link is different. I gave it a different text from the link itself, but all the standard options for Markdown are available to you. You can also save it as a text file, as we just discussed, and these are links to viewing this actual file as saved on my GitHub page. So you can pull this down and run it yourself. And as I said, because of this, I was able to use the diff functionality very easily to see what I had changed between different versions. And you can, again, because it's Markdown, you can just put a link to an image. So here I put an image in a images subdirectory, and I just link to it, and it shows up there, which is pretty cool. So here's Mermaid.js, and again, so let me show you this is what I typed in, and the example is pretty straight from this particular page in Mermaid. I think it may be identical. I forget if I changed anything, but the basic idea is just to try out different things. You use sequence diagrams, flowcharts, relationship, entity ERDs, and entity relationship diagrams, all kinds of things. That's just a sampling, and they've looked very cool. Another thing to know about is if you click this button, you will get all these keyboard shortcuts for LiveBook. And there's a lot of them. I won't go into them all. Just note that there's several modes. There's a navigation mode, which is when you're not inside. Well, insert mode is when you're actually, I'm not even clear. I've been doing this, but I haven't used a lot of these keystrokes. But I know there's a difference. Let's see. There's well, I just pasted them all here. Let's see if so when you're outside of everything, that's one mode. When you're in here, it's a different mode, and this shows up. I'm not actually know what they call the different modes, but you can play with that. But there's a few key things to recognize here. So saving notebooks happens pretty much automatically, I think every 5 seconds or something. This one I've used a lot. So this, and this may vary. I suspect if you're not on a Mac, you're going to have different bindings. But yeah, whatever this key is, I don't know what they call it on my computer. That plus the enter key causes the cell that you're in to evaluate. And if you do that, but with the shift key, it will evaluate all outdated cells. So if you want to basically recalculate your notebook, you can use that, and I use that a lot. There's a few others that I use. The autocomplete is tab, which is pretty standard, etc. But to be honest, I haven't played with a lot of these cells, these key bindings. But you can move cells around, evaluate outdated cells, and you can see it all by just clicking this button. Okay, so let's get into some Elixir. So let's start with anonymous functions. An anonymous function, so I'm going to use that key binding we just looked at. So it evaluates the cell. If you want more examples, here are some links you can follow to get more information. What's going on here is we're creating an anonymous function, meaning we're not giving it a name. We're just saying it takes an argument. We're calling the argument num, and it's going to return whatever this evaluates to, which in this case is whatever you passed in plus 7. So we didn't evaluate anything. We didn't pass any arguments. We're just defining a function. And we're not even storing this function anywhere. So there's no possible way to reference this function anymore. You just created a function with no name, so that and not assigned it to any other variable. So this is a pointless exercise, except to show you how to define an anonymous function. Here we're taking that same anonymous function, we're wrapping it in parentheses to make sure that it gets treated as a single object. Then this dot, which is different from a normal function call. Anonymous functions, beware, in Elixir require this dot. Normal function calls do not. So that's sort of how you distinguish an anonymous function from a regular function call. And then pass in any arguments here. So in this case, we're going to pass a single argument with the value 10 into this anonymous function. So 10 will get assigned to num, and then the result of calling this anonymous function with the value 10 will be 10 plus 7, 17. So let's confirm that math still works as we think it does. Yes. This is the same function written in a terser notation. So what this is saying is, this is called the capture operator, and we're basically capturing the function. And the function that we're capturing is using this &1 to indicate the first parameter that gets passed into the function. It's the value of the first parameter. And if there were more than one parameter, actually down here you can see there are 3 of them. So this is taking the first, the second, and the third arguments that get passed in and adding them together. In this case, we're just taking the first argument. So again, that just defines a function. It doesn't do anything with it. To evaluate it, we would call the anonymous function when pass in the value 10. Here we're passing in 3 values, 30, 30, and 40, and then we're evaluating them. This function is expecting 3 arguments, and then it's using the 3 arguments to add the values together. Here again, we're passing in 3 arguments, and just a different notation for the same thing. Here we're taking the anonymous function, which is the thing on the right, and we're assigning it, well, this equal sign is technically not the assignment operator, it's the match operator in Elixir. Since we haven't yet assigned anything to the variable add7, we can assign anything we want to the variable, or we can match anything to the variable add7 here. If this were already defined, we would not be, this match operator would fail unless we happen to have already passed this exact anonymous function into add7. But in this case, we're going to basically create a new anonymous function, and we're going to assign it to the value add7. So now we have an add7 function, which we can then evaluate. So because it's an anonymous function, we have to use this dot. 7 plus 8 is 15. Similarly, another anonymous function using the capture operator, assign it to add another 7, and then evaluate that with the value 8, and we get 15. Okay, so now modules. This is how you define a module. It's a pointless module because there's nothing in there, but that's the syntax for it. So now we're taking the same module name, and we're going to define two functions using slightly different notation. So def is for defining a function, and the function name is add2, and the parameter, there's only one of them, is num. The notation with the comma does not require, the comma and the colon does not require an end at the end, and this is typically used in short one-line functions. If you want to spread your logic out over to multiple lines, you probably want to use the do end block instead. So these basically do the same thing, except add2 is adding 2 to the number and add3 is adding 3 to the number. Just slightly different notation I wanted you to be aware of. So now we can call these things. We have a function, we call it on 4, and note there's no dot here. If this had been an anonymous function, we would need a dot to evaluate it and pass in the value 4. It's a named function, so we don't. Similarly here, 9 plus 3 is 12. Here, what we're going to do is, instead of spelling it, we don't want to type my module every time. That's just too much work. So what we're going to do is use an alias. So we're going to say, okay, whenever you see the atom m, consider that the same thing as my module. So then we can just say m.add3 and 5, and that does the same thing. Import goes a little further. So here, alias is simply saving you typing out the full thing. It's saying treat these two atoms as identical, and what import is doing is saying, okay, take all the functions inside of my module and put them into the current names scope. So I don't then have to say m.add3. I can just say add3. So should get 10. Hopefully we do. Yep. Okay. So now the pipeline operator. This is one of the things that people come to Elixir love the most. Instead of having nested function calls, which gets really nasty, and you have to figure out where's the innermost thing, and then you try to find the next outermost thing and see the evaluate, and then the next outermost thing. Instead, in Elixir, it's possible to create a pipeline. And what the pipeline is you take a single value and you pipe it into something else, and the value gets inserted as the first argument in the second piece of the step in the pipeline. And then the result of that, so the result of passing 7 into add3, is then passed as the first argument into add2 in this case. So this is going to be 7, this is going to be 10, and then we're going to pass 10 into add2, and hopefully we get 12 at the other end. Let's see. Yes, we do. So again, 7 here. So in this case, this is the capture operator. I should mention the /1. I don't think I've mentioned this. So this is arity. So what this is saying is, so arity is the number of parameters in the function definition. So add 3 in this case with 1 parameter. So we could have, so in this case, that is what we have. It's a one arity function. But in theory, we could have a 2 arity function, add 3. 3, num2. Let's try this out, make sure I'm not lying to you. So we can say 3 plus num plus num2. So I can reevaluate the cell. Okay, so it compiled properly. So let's try add 3. Let's try them both. I haven't thought about doing this before, but this makes sense. So well, we haven't added. So this one we're taking the one arity function, which is just adding 3. So 7 plus 3 is 10, and again, it's an anonymous function. Oh, so this is an anonymous function because we have captured it. If we were calling add 3 directly, this would not be an anonymous function. But here we're going to get 7 plus 3 is 10, and pass 10 in to this anonymous function and get 12 out the other side. Yep. So 7 plus 3 is 10, plus 2. So these are just equivalent ways to calculate the same thing. This also. Now let's try add, and this is another way, still another way to generate the same value. So here the difference is we aliased m to my module, so these two are equivalent. And here we're defining anonymous functions on the fly. So we're saying instead of defining an add 3, instead of creating an anonymous function and assigning it to add 3, or defining an add 3 within a module, we are just directly saying, okay, let's create this thing, and whatever you pass into it, add 3 to it and return that. And then we're saying, okay, it takes whatever we pass in from the first argument will be go into the ampersand 1 here. So it'll become 7 plus 3, which is 10, and then 10 will get passed in and put into this slot, the first argument. So 10 plus 2 is 12, and we already calculated that. But let's show the the other add 3. So we have my module dot add 3. So in this case, it would be /2 because there are 2 arguments. So, and then we're gonna have to do the capture operator. Capture operator, and we're gonna pass something. And what should we pass in? We're gonna pass in. Oh, wait a second. What I didn't do. I don't think I defined. Here we go. Yeah, this is going to take 2 values and add 3 to the sum. Right. Okay. So we need to pass it because this is a /2 here. This is going to expect 2 arguments. So we can either put them here. We could pass in 20 and 30, or we could pass in 1 and then send 1 in this way. So let's try that. We'll pass in 30 through the pipeline operator. So this will become the equivalent of just a single call to 30, 20. But we're going to leave out the 30. We'll pass it in. So we're going to get 30 in, and 20 will also get passed into the anonymous function. So we're going to be passing in 30 and 20 and then adding 3 to it. Let's see if this works. Yay, look at that, 53. Okay. So that's the difference between a /1 and a /2. You could have /0, meaning the function doesn't take any arguments. And in Elixir, they're treated as they're only treated as the same function if they have the same number of parameters or the same arity. So, and you can have multiple add 3s with different arities, and they would be considered separate functions. On the other hand, as you'll see in a few minutes, you can have a single function, or you can have multiple functions with the same name and the same arity, but those aren't considered the same. The different functions, they're considered one function with multiple clauses. So we'll see how that works and why you'd want to use that. Something a little more complicated, or actually, now we're just adding the pipeline operator. With the pipeline operator, you can put it all in one line, or you can put the pipe operator at the beginning of the next line. So this will do the same thing. The result of the second line will be 10, and that'll get passed in as &1 here, so you'll still get 12. It's just, what happened? I forgot to hit the other key. There we go. And this will do the same thing. Yep. Okay, so multi-clause functions. So again, so here this is 3 different clauses for what Elixir considers a single function. So this is a greet/1, as you can see here, greet/1, because each of these takes a single argument, and then depending on what the argument is that gets passed in, you get a different response. Actually, to be safe, this is presuming there's only 3 possible greetings, but we could actually get a different something. Let's call it something else. Sorry, I don't know you. Okay, let's see. Let's add that here too. So, yo, what's up? There we go. Where is it? There we go. And then, okay, so let's try this. So what we're doing here is we're defining a greeting module with 3 different, oh, you'll see the pop-up definitions here, by the way. So that's kind of, so when I hover over def, it's telling me where def is coming from. So it is a kernel function. So when you say anything that's in kernel, can be called without the module name. It's automatically included everywhere in Elixir. You get anything in kernel for free, and that is that's the exception to the rule. Normally, you have to specify the module that the function lives in, either through an alias or directly spelling it out. But kernel functions can be called without the kernel prefix or the kernel, the module name. But you'll see there's example code here that shows you how to define stuff. Talks a lot about it. So this is all available to you right here within LiveBook, which is just amazing. Under the covers, they're using the Monaco editor, which is the same editor that is used by VS Code. So we define the 4 different function clauses, they're called, and because these are all arity1 functions, so that it's 4 different clauses for the same thing. And then here we're going to run them. So we're just going to call them with different arguments, and hopefully we should see different responses. Oh, something else is unused. Oh, so yeah, the compiler is going to warn you if you define a variable and then don't use it. There's 2 things you can do. One is you can, that's not, that's right, plus, try again, make that bigger. You can prefix it with an underscore, and if you do that, you're saying, okay, I know there's something here, but I don't care what it is, I'm not going to use it. And there are times when you want to do that, and if I resave this, the compiler warning goes away, because the compiler is saying, okay, you know that you don't want to use this, but you're intentionally choosing to put a value there, that's fine, I'm cool with that. But if you don't do that, you can ignore these warnings, but I really like the practice of, there's a warnings as errors option in the Elixir compiler, so you can basically force warnings to blow up your compilation process if you don't want to basically ignore warnings, because projects tend to grow and grow and grow, and if people are ignoring the warnings, that's not a good thing, and unless you enforce them, they will tend to grow out of control. So I like the idea of warnings as errors, and as a compiler, inside of your mix file, you can actually make that an explicit option, so you don't have to say it when you actually do the compilation. Spell out, ask Elixir to compile your code; it'll just automatically happen whenever you do. Anyhow, so here is. Oh no, I got a typo here. Oh, I did something wrong. Oh, I put the question mark outside of the string. Let's try again. Yeah, there we go. Okay, so notice also that we get each of these lines generates output in the top part, but only the last line generates output in the bottom part. The difference is that these IO.inspects are side effects. So this is every function call returns a value. But when in LiveBook and in a function, in any sort of chunk of code, I think this is technically a block of code, only the last value gets returned. So in this case, we're calling 8 different functions here, 4 of them are explicitly requesting side effects. So print out this value. I want to see what this value is. So that's what these 4 things are here. And then the return value of all of this, which is getting displayed by LiveBook, is the result of this call, which is this. So that's the difference there. Guard clauses. This is a way to restrict when a function call happens. So we define 3 different prints, and I'm saying when the thing that you're trying to print is a binary, which is basically like a string. I won't go into the technical details of it, but it's basically like a string. Then just call IO.puts on the thing, and again we're piping the thing into IO.puts. When it's an atom, I want you to take the atom and then turn it into a string, and then display that string. Another option, what if it's a map? And these functions are defined in Elixir. You can, or they're I'm not sure if they're technically functions or they may be macros, but a lot of Elixir is written as macros. But these guard clauses, there are only certain things that you can do inside these guard clauses. You can't use any sort of custom function that you've created for yourself, because doing so could be unsafe. So Elixir doesn't want to let you shoot yourself in the foot. But you can see here, kernel has an is.map function. Kernel has a lot of is whatever functions to, if you want to check the type of something in a guard clause or somewhere else, you can use these is functions in kernel. So in this case, what I'm doing is I'm taking the thing, and since we know the thing is a map, if we're in this function clause, so these are 3 function clauses of a one arity print function, and we're distinguishing between them not by the value that, not by the, I don't know, the fact that there's one thing passed. Up here we did it based on whether you passed in this atom or that atom or whatever. But down here we're doing it based on what type that thing is. So is it a binary, is it an atom, or is it a map? And if it's a map, so we know it's a map. So then what we can do is we're going to do 2 operations here. We're going to map it into, so we're going to take the map. You can iterate through a map by getting key value pairs, which basically you can pull out using this sort of tuple. And then, so the key is going to be assigned to the value k, and the value is going to get assigned to the value v. And then we're mapping it into this string, where we're going to say take the key and then add a comma and a space and then put the value. So the result of the first part of this, the thing, and then this first Enum.map, is going to be a list of strings, where the strings look like this. And each element in the list is one of the key value pairs from the map. And then we're going to take that list of strings and we're going to call enum join on it with space comma, and so that's going to take any things that we have and join them together. In this case, we only are going to pass in one thing, so that's not really even relevant. And then we're going to print it out. So when we call print with a string input, we get yay, and you'll notice that OK is the return value, not yay. Hooray with an atom gives you hooray, and when a map is passed in, we get the hello world as well. So everything worked as expected, and so the bottom line is you can use these guard clauses of various kinds to restrict which types of inputs will get handled by which function clauses. Maps and structs. So we just showed some maps. Let's do something a little fancier with the maps. We're going to define a module, take some of the great Celtics basketball players from my youth, create maps with them, and then we're going to define a players list, a list of players function. And I guess if I do this, we're going to just, oops, wait, I keep hitting the wrong keystrokes. So I'm asking, so we're defining the module, then we're looking at bird, that's bird. Then we look at all the players, so it's a list of maps. We can get a little fancier. So here what we're going to do is we're going to create a team, basically, and we're going to import Celtics players, meaning we're going to make all the functions here, all these functions are going to be available to us without any aliasing or anything. We just can call them directly within here. So I'm just going to call team. So this team refers to, ooh, where's team? Wait, what's going on? Oh, this is the function I'm defining, right? Sorry. So this players call is going to be calling this players function here. So this is going to return a list of players where the players are maps. So, so this players is a list of all the players as a list of maps. Then we're going to filter through them. So to get the list of forwards, I'm going to say, okay, filter through all the players and just give me ones where the player has a position key with a value of forward, with this being an atom. And for centers, we're going to do the same thing, but we're going to filter out the players who have a position of center. And guards, we're going to take the players, find the players who have a position of guard. And so each of these will be a subset of the original list. So we're going to get, when you call team, you're going to get a map with 3 keys in it, forward, centers, and guards, each of which will be a list of players. And so then we actually call Celtics.team. Keep hitting the wrong key. And there's our list. So that's what we got. So now this is subject to error. And the maps are not really restricted. You can add random keys and values to them. There's not a lot of structure to them. Nothing gets enforced in terms of structure. If you want to get fancier, you can create a struct. To create a struct, so here I'm creating a player struct. So it's just a function, but with a special defstruct macro call. The defstruct, I think def and defstruct are both macros. With the defstruct, you define the keys that is possible to have values for, and then you can optionally add this enforce keys option and list keys that must have values. So you'll notice that team is a valid defstruct field, but it is not required that you have a value for it. Run this. So the player struct looks like this. Is that right? Yep. So we can actually see that here. So the Elixir will, when you define a struct, Elixir will create a _struct function on the module itself, and it will return basically an empty struct. You can actually call .struct on an instance of the struct. So this part of this, oops, that's not what I wanted to do. This part of this is identical to above. So this is returning this player struct, and then we call _struct again on it. And what do we get this time? And this is available on all objects of that type. So all instances of player struct will have this _struct as well, and it just returns player to tell you that's the type of struct you have as a player struct. Now we're going to do defimpl. What defimpl does is you're implementing a protocol. So there's a protocol called inspect. Again, you can get the documentation there. It says the inspect protocol converts an Elixir data structure into an algebra document. There is when you want to inspect an object, Elixir uses the inspect.inspect function, and you can override that or define a specific implementation for any sort of data types that you create. So in this case, we have a player struct, and we want to define our own logic for displaying or inspecting a player. So in this case, I'm going to override this. In defimpl is defimplement. I'm going to implement the inspect protocol for the player struct. And so whenever inspect gets called on a player, I want to do this. I want to say I want this brace, what do you call it, left arrow, less than sign, player number, and then their number, parentheses, player position, then colon, and then their first name and last name, and then a greater than sign. So we're going to redefine how player structs get displayed. when they get inspected. Now we're going to import Celtics players, which we defined earlier. We're going to, so this is called a module attribute. I think it's module attribute. It's like a constant that gets defined at compilation time. Anything you do at whatever gets defined at compilation time. So you don't want to do it for runtime stuff, but in this case, you can call the players function is also defined at compilation time, and because we're calling import here, Elixir's compiler will make sure that Celtics players is compiled before struct Celtics, and then it will let us leverage all the functions in there which predefine the players, so we can call it here to define struct Celtics. But we're not just going to display the players, we're going to map them. So we're going to take each player and we're going to turn them into a struct. So this function struct, and then the struct name, and then the map. We'll turn that map of the player map that we have for each player. It will turn that player into a player struct. It'll turn the map into a player struct. And so, since we're doing Enum.map, it's going to do it for all the players. So the result of struct players will be predefined. It'll be defined at compilation time as a list of player structs that was called from Celtics players. And then we can use that struct. So this struct players doesn't get calculated 3 or 4 times. It gets calculated once at compilation time. And then when anyone ever calls the team function, it will take advantage of this pre-calculated at compilation time data structure to return a map with 3 keys: forwards, centers, and guards. And each one will it'll loop through all the struct players and filter out by position. So this time we're going to get a list of players as structs. Wrong key. And you'll notice that they are displayed according to the logic of our defimple up above, where we defined how we want them to display information. They don't look like ordinary maps. One of the benefits of making a struct, defining a struct, is that you can't put in invalid information. So you'll see here I try to define a player name with just fname Bob and none of the other things. And we earlier said that there must be a lname, number, and position as well. And so when I try to create that player, it's saying that's illegal because you're missing lname, number, and position. Here, what are we doing differently? This is I think just a different way to calculate. Oh, here I'm adding in the team. So we had an optional team value on the player structs, and here after I create the players as structs, I then add in the team of Celtics to them. So I'm mapping over items, and then I'm mapping over each element is a struct is a map under the covers with a little extra magic to it. But you can treat a struct as a map for purposes of like calling Map.put. So Map.put is saying, okay, so here the &1 is saying, okay, since we're mapping over all the player structs, it's saying, okay, for each player struct that we're passing in, put into the key team the value Celtics. That's what this is saying. So this is going to give us exactly the same information as before, except each player is going to now have a team associated with them. However, they're not displaying here because we defined our defimple to specify. Where'd it go? Here. We did not specify anything about team in here. So these structs, they have changed because they now all have a team of Celtics. But when you display them out, you don't see that because the defimple has overridden and not displayed that value. And this actually got me in trouble down below, as I was explained, because I forgot about that. So here we're taking the tree. There's another way to display this. If you want to see the full raw information, instead of calling just plain old IO.inspect, you can call IO.inspect with structs false as an option. By the way, this is equivalent to, so this is a keyword list, which is, I believe, it should be the same as this. So let me, first of all, make sure I'm not lying to you. I'm lying. What did I do? Oh, because I forgot it's a keyword list, so it needs to be a list. Try again. Yeah, so let's see. This should work. Yay, okay, it does. So, and let me leave that in the notes here. Because this, back in the day, confused me. And it's one of those things that after you've done Elixir for a long time, it seems obvious, but it's not obvious to people who are starting out with Elixir. So, basically, whenever you have a list of tuples like this, so this is a list of tuples. In this case, there's only one tuple, but when the first element in the tuple is an atom like this, then you can rewrite the logic to be this. So this is exactly equivalent under the covers, but yeah, when you're starting on Elixir, that's bizarre. So that's what's going on, and you could do the same thing if there were 5 tuples in there, each of which had a key of an atom key. You could do the same thing. So here I'm printing out the raw information, just treating them as maps. So this is like a map of information here rather than it's displaying it as a map. So you'll see that it is a typical map with the 5 fields that we explicitly stated. And then there's this one other field of _struct, which is the player, which is basically the thing that we called earlier. So we get the list again. Okay, so let's get to some testing. So the main way to test Elixir is using ExUnit. ExUnit gives you the ability to do all kinds of example-based testing primarily. We'll do a little property-based testing below, but let's start with the basics. So in this case, I'm requiring struct Celtics because I want to test it. I'm calling .team on that module, returning the value as Celtics. I'm going to test some logic here by basically saying, okay, let's get all the forwards, all the centers, and all the guards there, and we'll call that players. I want to see all the players, although I guess at this point I don't need to see that. And then I'm going to define by hand a single player, and I'm going to see if he matches. So the player, so this is a way to sort of the manual way of defining a player, struct, a specific struct is do the percent and then the struct name, and then the required keys and any optional keys you want to add in. And then we're going to assign that to the variable Kevin. And then I'm going to assert. This is the key for ExUnit. This would be equivalent to refute Kevin. Actually, Kevin not in players. I think you can do that. I've never actually done it that way because it doesn't even make sense. But there's an assert and there's a refute. Assert is expecting a true value, so it's saying this should be true. Refute is saying this should be false. And your test will pass if assert returns false. You're asserting on something that evaluates to false, or if you refute on something that evaluates to true. And then so here we're just going to call ExUnit run. Usually you don't have to do this explicitly. Usually you're in a test situation in a Mix project or something. It's easy to do, and there's a logical structure to it. In a LiveBook, you have to sort of do a little manual work yourself here. So this is where I got into trouble. I looked at this and I'm like, wait, why isn't this passing? This looks exactly right to me. So I asserted that Kevin was in players, and I see player 32 forward Kevin McHale right there. And there's player 32 forward Kevin McHale. And I forgot I had added that extra field, and I didn't display it in in my defimpl. So there's an additional field of team, and the right-hand side players objects include the team Celtics, but the Kevin that I defined manually here, I didn't define a team, and so it implicitly turned it into team nil, which does not match team Celtics. So this was false. I was like, well, why is it false? The easiest way probably was to add in these inspects, and once you add in the inspects and stare at it, as long as you turn on the structs false, you see all the details. When you don't include the structs false, you don't see the team information because you've overridden inspect. So anyhow, this is how I actually found it, but or actually did I do that? I forget which way I actually found it. But this is one way to actually find it. And so I tricked myself through my code here, but okay, so this didn't work. I ended up pulling out an old library that I had built a number of years ago, 3 jobs ago, I think, which I've ended up using at every job since. It's I built this at Teledoc, but I couldn't get it open sourced, and so over the weekend I just rewrote it from scratch, and I think it came up better the second time from scratch. Anyhow, I've used it subsequently and found it quite useful. And so that's what I went to try to figure out what the heck was going on. What I did was, so my library is called RecursiveSelectiveMatch. I alias it because that's just way too long. So I always alias it as RSM. And I do the same thing. I define the player struct. Well, here it's actually working because I realized at that point that I needed to add the teams. But when I first started this, I didn't. So I ran the same test with this cat. Well, I guess I can show you here. Commenting out the below is going to be tricky, but when I did this, let me see. Let me just do it. I can do a little typing here, but it's worth it. Okay, so now we evaluate this. So what my library does, it says, okay, I was expecting truthy. So RSM includes. So this is what this is doing. And with hindsight, I wish I had reversed the order of these, but includes is say there's it's saying, okay, this item should be in here. So this item has to contain this item, is what that's saying. And to my surprise, I got false. I was like, why not? So it outputs the information. So it's saying this is what I defined, and this is what is actually in the right-hand side. And you'll note the team Celtics jumps right out at you versus team nil. So that's how I resolved it. And then I realized, I think that's how I figured it out. And then I went back and realized, oh, if I had done structs false, I would have seen it up here as well. But because I had overridden inspect, I didn't see that extra piece of information, which was tripping me up. So that's enough for today. We've covered a lot of ground. Hope you've been able to follow. If not, you can rewind and rewatch. You can post questions in the YouTube room. And I will hopefully get around to another recording tomorrow night where I'll step through MyVal. If you want to poke ahead, you can look at the GitHub repo. I've already posted the code there. Thank you so much.